to hear them complain about it. I didn't think it was the end of the world.
Right. How to identify the stable electron configuration from a list. So, it's the same idea as the question we just went over, but now we're going to give you the configuration, and you have to tell us which is the stable ending. And instead of writing out the whole thing, we're just going to deal with that valence block. So let's write down one that we know from this is I need the marker blue. Okay, is incorrect, because we just found out that 3D, they're one behind, 4s2, 3d4 is not stable. In fact, d4 doesn't exist. Well, I mean, it's there, but we never see that in a configuration.
Yeah, it only exists on paper.
Right. So this would be an example of an incorrect configuration to show stability. But 4s1, 3d5 would be stable. How could we change up these answer choices? Well, I mean, honestly, about all we can do is say, okay, 5s2, 4d4, or 5s1, 4d5. And just change the energy level. There's no big mystery in what can be done to this problem. But you're looking for that d5, because you know there are 5 d orbitals, and at least having one electron in each is going to make the atom somewhat happy. Mm-hmm. Not the super exhilarated joyfulness of the full valence shell, but
or
at least
a chemistry student at West Virginia.
Oh yeah. Acing this test.
Yeah, that's right.
All right.
Number 37.
Yes.
The orbital description of electron placement in an atom.
Right. So this is going to go back.
That's going to go all the way back to the first thing we did in this whole flipping experience in the
dropping the marble.
The classroom, dropping the marble, and identifying the arrangement of the electrons around the nucleus as a region of high probability.
Probability is the key. We looked at that as a graph.
Mm-hmm. That sort of bell curve, that probability curve.
Probability curve. So there was an area at a certain distance from the nucleus that was more stable. We also saw it as a bunch of dots, and a lot of them were close and not so many were far away. Probably the electrons are going to be found closer to the nucleus.
Yes.
Alrighty. Ooh, short answer time.
Yeah.
So 18, 19, 20, the last, test hints, whatever.
18, 19, 20.
38, 39, 40.
Yeah.
And those are your short answer, where you are going to actually write out electron configurations and orbital notation and electron dot. Ooh,
electron
dot. Electron dot. We haven't asked you any questions about electron dot till here in the short answer, which is okay because it's the easiest kind anyhow. Yeah. And then there will be one bonus question on quantum numbers, which we will hopefully be getting to throughout the flip section, like actually distinguishing those. We think you'll have fun with those.
Yeah. It's a bonus.
Right. So, we're going to pick an element, and we want you to write all the types of electron configuration. The 1s2, 2s2, 2p6 stuff, the arrow diagram or orbital notation, and the electron dot.
Yes. You have to do all 3 parts.
All 3 parts.
You've got to be able to do all 3 parts.
So these questions are going to be worth multiple points, not just 1 or 2 like we usually do. So multiple parts. Why don't we show them an example? Let's go from here to the dot diagram, because we haven't given an example of dot. So we know, well, this is our orbital notation.
So this is our chromium.
Right. And do we want to do, let's write out the electron configuration and do the dots.
Want to do the electron configuration here?
I think over there more, just because we're cutting off space.
All right. So electron configuration notation is the 1s2, 2s2, 2p6. The electron configuration is really slick. 1s2, 2s2, that was a little too much, I think. 2p6, 3s2. You know what else is weird? In my head,
You're singing it.
No. I have a picture of the periodic table in my head, and I'm just going, okay, yeah. Okay, magnesium, and then 3s2, 3p6, 4s2
What?
calcium.
What? Chromium?
Well, I was getting there.
Okay, fine.
I was getting there.
Okay.
Let's do 4s2. Chromium has 24 electrons, and right now I'm up
I
to.
don't think they can see it. You're standing right
Oh,
there.
yeah. Well, see,
I know you're lefty.
I'm lefty. 2, 4, 10, 12, 18, 20, and then 24. That would be 3d4. But I know that that doesn't happen, so I got to do this.
Right.
Hujamababi. Actually, I could have just used this
As the model.
to cheat.
Right. Well, you had to write that
Use
anyhow.
my own work to cheat because I have to do this anyway. 3d5. So there you go.
Okay.
Where's
We want to do the electron depth.